Hey guys, welcome to today's lesson looking at the differential calculus application style of questions. So far we've been through all the different types of differentiation, from first principles to our shortcut methods, and then obviously our three different rules of chain rule, our product rule, and the quotient rule. And each of these rules have been the aim of finding the differentiation of those things, okay, is because we want to find the gradient of the curve at a certain point. Now, we'll be looking at, and in terms of finding the gradient of a curve at a certain point, we've been looking at what we call tangents, okay. So obviously, if we're given something like this, the curve y equals x squared plus 1, and we're asked to find the gradient at the point, let's say, x equals 2. So what we've done there, we've differentiated it to make it 2x, and then said therefore at x equals 2, the gradient equals 2 times 2, which is 4. Okay, so that's what we sort of mean by application questions. And then what we can actually do, we can actually find the equation of the tangent at that point. Say, for example, the point was, let's say, 2, 4. Okay, so x equals 2, y equals 4. If we want to find what the equation of the tangent was there, then all we have to do is put it back into the y minus y1. So y minus 4 equals my gradient x minus x1. Okay, which gives me y minus 4 equals 4x minus 8, and we write it as general form 4x minus y minus 4 equals 0. So when we're looking at the application style of questions, they'll be looking at finding the equations of tangents, or the value of the gradients at a certain point, but also they'll ask you to find the equations of the normal. Now, hopefully, if you reflect back to our coordinate geometry, you'll remember that a normal is perpendicular to the tangent. Okay, and because it's perpendicular to the tangent, we know that if we multiply the two gradients of the normal and the tangent, that they equal -1. Or, for example, they are the negative reciprocal of each other. So, for example, if we looked at this question, which we've just done, and we wanted to find the equation not of the tangent but of the normal, then instead of the gradient being 4, it'll be -1 over 4, and then we can go through the same style of things, being y minus 4 equals 1 over 4x minus 2, blah 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 blah. Okay, so the whole idea of application questions is to find either the gradient of a curve at a certain point, and then perhaps to find the equation of the tangent at that point, or the equation of the normal at that point, or maybe a bit of mixture of sort of both. So let's have a look at a question here. So we're going to say here, find the equation of the tangent to the curve y equals 2x cubed, 2x cubed minus 7 at the point where x equals 1. Now, looking at this, something that's going to be useful for me, because we're finding the equation, we know we're going to at some stage need to find the gradient, and we need to find an x and y point. We've got the x point there, so we can easily find the y point by putting in x equals 1 into this. So y would equal 2, 1 cubed minus 7. So y is equal to, well, 1 cubed is 1, 2 times 1 is 2, 2 minus 7 is minus 5. So we can use our coordinates there of our point as 1 and -5. That's very important. We will need that at some stage. Doesn't matter what sort of order you do that in, okay, but as long as it's done at some stage. So in order to find the equation of anything, we need to have, of any straight line, I guess, you need to have a set of coordinates, and you need to have the gradient. So let's now focus on finding the gradient. Now, we know that finding the gradient is by finding the derivative of the curve. So let's do derivative of this. So 3 times 2 is 6x squared. Derivative of minus 7 is nothing. So we know that the gradient is given by the expression 6x squared. So at the point x equals 1, then y dash, which is equal to the gradient, is equal to 6 brackets 1 squared. So we're just substituting in x equals 1, which is equal to 6. So now what we've got a gradient of 6, we've got a set of coordinates, so we're going to put that in. Y minus y1 is equal to m brackets x minus x1. And let's always put it as a general form. So y plus 5 is equal to 6x minus 6. Therefore, 6x minus 5 minus 11 equals 0, and that is the equation of the tangent to the curve. Now the good thing is, the only difference when you're trying to find the equation of the normal to the curve is where you would just use negative 1 over 6 as your gradient, and the same points would apply. Now obviously this is one of the more challenging questions because they only gave you an x coordinate, so you had to put the back in to find the y coordinate, and that's about it. Obviously the harder differentiating is going to happen, the more challenging the question will be. So let's have a look at a significantly more challenging style of question. We're going to find the gradient of, so say find the equation of the normal to the curve. Let's say y equals x squared minus 9x plus 20. Okay, so, and we want to give a point, let's say, we'll even say at the point where the curve cuts the x-axis. That's even more challenging, hey? Okay, it's a pretty cool question. So at the cut where the curve cuts the y-axis, so if you cuts the x-axis, sorry, I need to put that there, the x-axis. Okay, so if you think about my curve, x squared minus 9x plus 20, if it cuts the x-axis, which is going to be here, obviously that's my x-axis, it's going to be looking at the value of y equals 0. So what we need to do is put 0 in here to find out what my x values are going to be. X squared minus 9x plus 20. Now there's lots of different ways that you could probably solve this. You know, you could do your product and sum method, I guess, or your cross method, depending on what you do. I'm going to use the product and sum method and have a quick look if this will work. I'm looking at this and thinking 5 and 4 will probably work. So x minus 5, x minus 4 equals 0. Therefore x is equal to 5 and x is equal to 4. So I now have, in this case, I've got two different coordinates. I've got the coordinates of 5, 0, and I've got the coordinates of 4, 0. Okay, so when I actually find the equation of the normal to the curves, there's going to be, where the curve cuts the x-axis, there's going to be two different equations here. So let's have a look at the first one. So let's find my y dash, or my dy dx. So we've got 2x minus 9, if I derive that correctly. So at the point x equals 5, our gradient is going to equal 2 times 5 is 10, 10 minus 9 equals 1. At the point x equals 4, my gradient will equal 2 times 4 is 8, 8 minus 9 is negative 1. Okay, so we've got two different gradients here. So let's now substitute those in to my formula. So the first formula, we're going to use our y minus y1, so we're using the point 5, 0 to start with. Okay, so y minus y1 is equal to m brackets x minus x1. y is equal to x minus 5. Therefore, x minus y minus 5 is equal to 0 is the first equation of the normal. Then of the second one, y, we did that wrong, didn't we? Hopefully you picked that up. What do you reckon we did wrong there? What you may have figured out, we did the equation of not the normal, but we did the equation of the tangent. So be careful, our equation, our gradient of the normal will be -1, okay, because negative reciprocal. So actually, that's my bad. Hopefully you picked that up. It should be -1 times x is -x, and then that makes it a positive 5. So actually that makes it as x plus y minus 5 equals 0. Ooh, lucky I checked that one out, hey? Okay, so for the next one, again, we're going to, in this case, the gradient of the norm will be 1, okay, because it's a negative reciprocal of -1. So y minus y1 is equal to the gradient, which is 1, x minus x1. So we've got y is equal to x minus 4, therefore x minus y minus 4 is equal to 0. So you've got to see, you've got to be really careful with this stuff. I have made that mistake because you've got to figure out, am I finding the equation of the tangent or am I finding the equation of the normal, because it does make a fairly significant difference. Okay, we're going to look at a different style of question now. So this will be EG3, I believe, I think. Let's have a look. So we're going to say find any values of P, if the tangent to the curve y equals px squared minus 6x minus 3 is parallel to the line y, we'll do 5x minus 3y plus 2 equals 0 at the point x equals -3. Okay, so it's a bit of a mouthful again. Alright, this looks to be quite a challenging question, but to be honest, it's not too bad. First of all, one of the important parts is that we need to find, obviously, a gradient and an x and y coordinate. So we know that the gradient is parallel to the line, this line here. So if I know what the gradient of this line is, then I've got the gradient of my curve, because it is parallel, and we know that if two gradients are parallel, they must be equal. So let's put this in the format of y equals mx plus b. So 3y equals 5x plus 2. So y is equal to 5 over 3x plus 2 over 3. Therefore, my gradient is equal to 5 over 3. Okay, so that's fairly significant. So we know that if we need to find out what y dash is equal to, okay, it's equal to, let's differentiate this term. We can still do it with the p there, because that just represents any number. So 2 times that number, so 2 times p, x to the power of 1 minus 6. Okay, so we've differentiated that, remembering that we're trying to find p. Now, we already know what the value of the gradient is, or y dash, because we got told that that had the value of 5 over 3. So 2px minus 6 equals 5 over 3. So 2px equals 5/3 plus 6. Okay. So 2px is equal to 7 2/3. Now, it says at the point x equals -3. So let's just put the -3 where the x is now. So 2p times -3 equals 7 2/3. So -6p equals 7 2/3. Now, to get rid of the -6, because it's -6 times p, we're going to divide by -6. So what we need to type in now is 7 2/3. We're then going to divide it by -6. Okay, we get a p-value of negative 1 and 5/18. So for the answer, which says find any values of p if the tangent of the curve is parallel to that line, well, the value of p is negative 1 and 5/18. Look, that's quite a challenging question. They're not going to get too more challenging than that. Again, I guess if you just remember that the equation of the tangent, you need to find your set of coordinates. So we might write this down actually. Okay, so for any of these application questions, okay, we need to have a set of coordinates, and second thing we need to have a gradient. And be careful, because for the normal, we need to make sure once we've found our y dash, okay, we need to take the negative reciprocal. Remembering that m1 times m2 equals negative 1, because the normal is perpendicular to our tangent. Okay, I hope you found this useful. If it's confusing, again, give me a bit of feedback and I'll redo this one to make it a bit more clear. Have a good one, guys.